Now that we know how the setup should look, let's actually solve and complete the decomposition. So I notice in this example that the denominator can factor into x minus 3 times x plus 4. And we know that that means I can rewrite that as a over x minus 3 plus b over x plus 4. Now, to solve for a and b, just imagine that you're on the right-hand side of this expression or this equation, and you want to combine these two separate fractions to get 1 with a common denominator. So you need a common denominator. That common denominator is, of course, x minus 3 times x plus 4. And so the way I think of it is, this first term, what is the denominator missing that the common denominator has? Well, it's an x plus 4. So I'm going to multiply the top and the bottom by x plus 4. Likewise, the second term, what is that denominator missing that the common denominator has? It's missing an x minus 3. So I'm going to times by x minus 3. And what this means is, since both expressions have the same denominator as the term on the left, we can just equate the numerators. So that is no longer necessary. And we can say, well, this means that negative x plus 10 is equal to a times x plus 4 plus b times x minus 3. Now our goal is to solve for a and b, and there are a couple ways you can do it. You could distribute and kind of collect terms in front of, collect the terms in front of the x, collect the constants. That works. I'm going to do it a different way because I think in the long run this way will be helpful. So notice this is an equation. It needs to be true for all values of x. So in particular, it needs to be true when x equals negative 4. So that's a smart value to plug in because it's going to make the term with the a in it go away. So let's plug that into this equation. When x is negative 4, the left-hand side becomes 14, and the right-hand side becomes, well, the left term goes away, and all we have is the b term, so it comes negative 7b. So that means b is negative 2. Similarly, if I plug in 3, the left-hand side becomes a 7. The right-hand side only retains the a term, so I get 7a. So that means a is equal to 1. And so now we're done. So therefore, negative x plus 10 over x squared plus x minus 12 can be decomposed into 1 over x minus 3 plus negative 2 over x plus 4. So there's the decomposition. Let's do another example. Let's try to decompose this rational function. So the first thing we need to do is factor the bottom. And it looks like I can take out an x, so therefore I get x times x squared minus 2x plus 1, which itself is factorable, and it becomes x minus 1 squared. So that means that this can be expressed as, don't forget we have a repeated linear factor, the x minus 1 squared. So that's why you need to remember it's going to be a over x plus b over x minus 1 and then c over x minus 1 squared. Okay, so now we solve. So I would identify what the common denominator is, and it looks like the common denominator is clearly an x and an x minus 1 squared. So what is this first term lacking that the common denominator has? it needs an x minus 1 squared, so I multiply the top and the bottom by that. The second term, the b term, is lacking another x minus 1 and an x, so I multiply the top and the bottom by that. And finally, the last term is just missing an x. Now that the denominators are identical on both sides, they can be ignored, and I can set the numerators equal. Okay, so now let's just let's use my method that I used last time, which was to pick convenient values. So x equals 1 is a convenient value. When x equals 1, the left-hand side becomes 2. And the right-hand side, well, notice that the first two terms go away because they have the x minus 1 term. And then we just have c times 1. So that was easy. Now we know what c is. Another good term to x value to plug in would be 0. And the left-hand side becomes 2 again. The right-hand side becomes negative 1 squared times a, which is just a, and then the other two terms go away because they have the x term in them. So at this point we've run out of convenient values to plug in because x equals 1 and 0 are the only zeros of these factors. So the next thing to do would just be to plug in any other somewhat convenient value. So I'm going to plug in 2. When x equals 2, the left-hand side becomes 4. And the right-hand side becomes a plus 2b times 1, which is just 2b, plus 2c. Now, of course, this has 3 unknowns in it, but we already know what a and c are, so we'll just plug those in. 4 equals 2 plus 2b plus 2 times 2, and solving yields that negative 2b equals 2, and that means that b equals negative 1. So our decomposition is x squared minus x plus 2 divided by x times x minus 1 squared is equal to, so a is a 2, so 2 over x plus b was a negative 1 over x minus 1, and our c was a 2. And we're done.